Hey guys, I'm Nick. I'm an architectural designer here at Hume Architecture. Today we're going to dive into one of these projects that we've been showing off a little bit. This project is located up in the Adirondacks of New York. It's a really beautiful site. We did the carriage house. You may have saw some videos on the build of that. That's been going really well. We're transferring into the house portion. We're going to get started on demo here shortly. So these plans are getting to a stage where we're getting ready to send out foundation and other technical documents that need to be forwarded out for material suppliers and for permitting. So today we're going to look at some of the structure elements that go into the design, some of the behind the scenes nitty-gritty of the day in the life really of architect or an architectural designer, what goes into some of the house details that you might not notice just from looking at a house or walking through it, but some of the things that really take some time to flesh out and to really nail down and get perfect. In this case, we're going to start out, we've got a 3D view of the house here. Now this is a timber framed home, just like that carriage house. So the main construction here, as we start from the ground level here, we've got SIP panels. So these are cast walls basically for the foundation. This will be a crawl space in this case for this house, so we'll have 5 foot head height between slab and floor structure. What's nice about that system is they can excavate, drop the panels all in the same day. It's really quick and dirty. It's nice. The panels end up being spot on. They're perfect when they level them off. So we really like using them as a good foundation to build the rest of the house on. And then we have SIP panel and timber construction. SIP panel being super insulated panels, or structurally insulated panels, sorry. These panels are attached to basically a timber frame. The frame is like a skeletonized structure on the inside, and then they're fastening those panels on the outside. So we have a lot of interesting ways to carry loads down to the foundation. In this case, you can see we've got one main core going through the building here, gable end to gable end there. And then we've got a larger gable end to gable end there. And we have an interesting intersection there. This is the main entrance of the house right here. So we've got 2 complex timber frame cores essentially slicing through each other. Now we've got some girts you can kind of see here. These girts that line this full length of this core, as I'd like to call it, all the way through from the kitchen back in here, all the way through living room, entry, and dining space on this side. These girts are carrying all of the load of these timber rafters in here. We've got a few occasional timber trusses in there. You can see these 2 here, and on the ends right before the intersection. Now, because of this, we have our loads on these girts that are inset a little bit. So we're going to jump into a floor plan here, and we can start to talk about, there's a column grid. So this is that layout we talked about, the kitchen through the living room, entry, foyer space, and dining space. Now you can see what I've denoted here is we've got columns, big timber columns that land at these spots. Now these points are taking the majority of the roof load. So the problem arised here is typically you're landing your loads on the exterior wall, and there is still a little bit of load landing on those walls, but the majority of that load is going down through these timber posts supporting majority of that roof. So being offset of our foundation wall, obviously that presents some issues. So we had to have some considerations when designing this. Having this girt and timber column offset from the exterior wall is a really nice touch to the overall design of the timber package, just because you get some of those elements brought inboard of the house, creates some more intimate spaces, adds a little bit more variance, and really starts to flex on the timber structure itself, where you really start to see a lot of the visual structure there. Column grid, that's one of the foundation things we can talk about. Second one being is we have interior load bearing walls. So we've got this wall, this wall, this wall, and the very important this wall right here. that are carrying roof loads and second stories. So on this half here, we've got a second story. We've got a stair up to that second story there. And it's really important that this load-bearing wall was there, so that way the SIP panels have structure to land on. Now this needs to be lined up with a beam down in the basement. So we have a series of beams that I'll show you here in a minute that work well with this. So we're jumping into, this is a drawing I did just to spec out the floor structure. So we've got 16-inch open web floor trusses right here. There's a series of them. And then these darker hatched regions we've got here are denoting LVLs. So in this case, we don't have any beam pockets. We're not doing beams below floor structure. In this case, we really want to conserve all of the head height we can in that crawl space, so that way ductwork and mechanicals don't need to drop down below beams. They can be all right below the floor structure and look nice and tidy and be the most efficient. So in this case, we're running a lot of our floor or our beams in line with the floor structure, right in the same plane. So we've got those same load-bearing walls for the second story right there, those two. And we split that load with a simple tiger post and a footer below it. So that takes care of that second story there. Additionally, we've got roof load being carried like the second story on this side. So then this whole half here, this long wing on this half of the house, is all 16-inch open web floor trusses running in that direction with mid-span LVLs supporting the load-bearing walls. So this kitchen half up above, these open web floor trusses needed somewhere to land on. So we'll have joist hangers that land them into, we've got 4 LVLs here. The reason we went with 4 is because we also have, if you remember in that floor plan, we also have a column up above, timber column, that lands slightly outboard with a foundation wall there. So then we've also got a column and a footer below to catch that load. So that's a really important moment. We're catching 2 timber columns, which is bringing roof load down at a very important intersection. And then we also have all of the floor structure here being supported by this beam. So this beam is a really important one. That's why we added 4 of them there, just to really make sure that it's stout. Another thing when we're thinking about these beams is the floor material. There's a real chance, it's not decided yet, but there's a real chance that we're gonna go with some real stone tile. Obviously we've got to bring in the weight of that into this equation. So we're overbuilding a little bit. Just in case we call an audible on some of these floor materials, we can handle the weight of that. Now in this living room section, you can see we've switched to floor structure running this way. Now this is just because the span works out better. Line your floor structure up the same way the roof structure is going. So in this case, very easy section. Just run it foundation wall to foundation wall. We don't have any of those timber posts landing on the floor structure. We'll talk about that in a minute. But then we switch back to this direction for this entry space, going this way. Now this is supported by tripled up and another tripled up LVL on either side. Same deal, we'll do joist hangers on that side. We've got mid-span tiger posts or other steel posts with footers catching the mid-spans of those. And then it continues on same way on this side. Very simple, running foundation wall to foundation wall. So now, those timber posts, we didn't really want those to land on the floor structure and rely on the floor structure itself to be strong enough to catch both the weight of the timber package and also the roof load that's landing on it, just because that is not directly on top of the foundation wall. So what we've done is we've actually had the company that's doing the precast foundation precast some isolated footers for us to use. So those will be placed below the slab, and we have them spec'd and sized in order to carry the certain point loads for each timber post. So in this drawing, we've got our steel posts in the crawl space. Right now I'm highlighting all of them. So these all land directly under a timber post or an LVL for load-bearing wall. These ones specifically here, we've got 4 foot by 4 foot isolated footer pads on each corner. Now these take the most load out of anything else in the house here. And these are some really big 12 by 12 timbers that are landing in these spots. You can see just barely off the foundation wall, but it's nice to know that we have from roof panels to timber trusses or timber rafters, down to girts, down to a timber post. Now this timber post is going to land into the subfloor, and directly below the subfloor we're going to receive that with a tiger column or another steel column right down to footer. So from roof all the way to the footer, it's a solid connection. There's no floor structure essentially in the way. And then we also have the same thing happening with these smaller timber posts in the middle here. These don't take as much load, so these size down to a 2 foot by 2 foot pad. And then we have some over here. They're more of a median size, so we have 3 foot by 3 foot. Now we had some point calculations done in order to size these, both by the timber company and by the company doing the precast foundation walls, just to make sure that we had adequate foundation for these. So when we're talking about slab precast foundation wall, right here, we got some stone below that, right, stone bedding. And then we have floor structure, or we got a sill plate floor structure up above that, like that. And then we've got a really big 2 by 12 timber that comes and lands right into that floor, just slightly offset of the foundation wall. We're basically putting a footer pad below the slab here. So we've got footer pad and slab, and then what we're going to do is receive that with steel post that will take that load from this timber right down into a footer pad there. So that'll be a really good way to handle those loads. Now, this is really important when it comes to architectural design. You know, you have a column grid, you have other interesting structural features, but you need to have a logical way to deal with those things. It's oftentimes like a cantilever in architecture is one of those things that is really appealing to the eye, but is super difficult structurally. Oftentimes is really expensive to do so. In this case, we found a pretty good workaround. The isolated footer pads were not too big of an added cost and ended up being worth the detail of having those timbers and girts inboard of the walls, so you see all of those features. So this is just a little bit of the nitty-gritty that goes into house design. A lot of times clients won't really see a lot of this just because it's at the surface kind of boring technical documentation when at the end of the day when you're looking at that. This is something we'll send over to the foundation company. They'll verify and send back to me, and oftentimes we don't really mull over these details with the clients just because they don't really care about point loads. But this is an important step that we have to take to make sure that the design is successful and that the building lasts a really, really long time, because that's our first goal, is to really build a solid house. We want it to look good, but we also want it to function well and be quality. So yeah, this is a little bit into that kind of foundation design. It's a little bit of a unique one, so figured sharing this would be worthwhile. And we'll be carrying on this series talking about this house as we get into the building phase of it. There'll be some videos of this foundation going in. We'll probably highlight some of these timber to steel column aspects once those are on site, and I look forward to it. It's going to be a really exciting project. Winter is almost here, so we're racing to get some foundation in the ground. Hopefully we can get a slab poured before it's too cold for that, but if not, push it off into the spring and we'll hit the ground running in the spring. But Thanks for watching.